I'd like to thank my dear friend Sir Nicola for inviting me. And I showed the situation that is a new advance in corneal refractive surgery and in corneal surgery. We know that in the last 30 years, we have a real advance in refractive surgery thanks to all femtolaser, because you can see that we passed from arcuate keratotomy, radial keratotomy, to all laser surgery. And we know that today it's possible to apply this technique also in this situation, in a small incision lenticle extraction after deep anterior lamellar keratoplasty, particularly when we have a residual refractive error like myopia, like astigmatism after dark, as a minimally invasive approach. Here it's possible to remove until 12 dioptries of the myopia, 5 dioptries of astigmatism with this minimal invasive technique that is the SMILE that you know, we published it 3 years ago. But the question is, for keratoplasty, we know that it's possible to perform in perforant and at different shapes, and in ALK, anterior lamellar keratoplasty, in different depths. You can see here that in a similar situation like post-infectious trauma scar 3 months after LK, you can see that it's possible to remove this part of anterior cornea that we cut with femtolaser before, and then we remove with a precise cut in the 90 degree. And you can see here that we can perform this top tail arc. That is very important because we reduce the astigmatism, we reduce the cylinder, we reduce the suture, and we have a real good result. But the question is, when we have the keratoconus, it's possible to perform a DALK, deep anterior lamellar keratoplasty with femtolaser? The answer is no. Why? Because the regularity of the residual stromal bed affects visual result. You can see here in this next slide that we have the difference between the regular and irregular that we perform the keratoplasty, the deep anterior keratoplasty with femtolaser. Here that is not keratoconus, we have a good result, but not good results here because we have the irregularity of the residual stromal bed. At this point, we have only one way. The only way is to refine, to restore the regularity of the cornea without subtraction, but with addition surgery. We know that when we perform SMILE, we remove tissue that is still vital, and it's possible the cryopreservation, and because we have a good cells, a live cells, and it's possible to reimplant this lenticle in animal and in human too, particularly in hyperopia. You can see here that is this paper when we perform the implant of this small lenticle of myopic lenticle to correct hyperopia. But we know that when we have ectasia, the question in ectasia, if we perform this situation in ectasia, it's useless to put this. Why? Because in ectasia we need of 2 aims. First is corneal thickening. The second is central flattening. It's contemporary to restore the problem of the cornea in keratoconus. If we put this, it's useless because we have the increase of curvature. We have thickening, but increase of curvature is correct to implant a negative meniscus, but because in this situation we have contemporary the flattening and the thickening. You can see that we performed this situation and published it the last year, this study, and in eye bank cornea we prepare this negative meniscus, and with inserter that we designed, we implant after the pocket that we perform with femtolaser, we implant this disc in this pocket. And you can see that we have these results that corneal profile, curvature, and thickness change after lenticle implantation. And you can see here in anterior segment OCT, you can see the implantation of negative meniscus and the difference that we have in preoperative and postoperative of thickening and flattening. Here, why? Because theoretically we have two laws. First is the thickness law due to the implant and the thickness of the implant. And the other is the arc shortening effect. It's the same effect that we have with corneal ring. Because when we perform and we put corneal ring, we have the arc shortening, but we haven't the thickening contemporary. And this is very important. This is the problem why we have the fail often. This is, you can see here before and after, preoperative and postoperative, the corneal map, and you can see that we have flattening and thickening. But in keratoconus, it's possible to translate the situation in keratoconus. The hardware is possible. And we performed this situation. We prepared in artificial chamber a keratoconus with the cornea or bi-band cornea with an excimer laser. We treat this and prepare a keratoconus model example. And you can see that before and after. After that, we perform this that we call stromal lentoid addition keratoplastic, SLAC. That is the technique that we put this, and you can see that change the curvature, you can see that change the thickness, you can see that change the flattening after. And now this is the model in anterior chamber model, pre, before, and after the lenticle implantation, and this is a differential map. And you can see the flattening that we have. At this point, we pass on the human. On the human, the question is possible on the human with this mini-invasive stromal transplantation for corneal reshaping in keratoconus, and you can see that this is our study, 10 cases of advanced keratoconus with severe curvature range that you can read here, and the transparent cornea. This is the visual acuity, the better, contact lens intolerant, obviously, stable keratoconus, candidate for DALK or PK, and the lenticles were obtained from I-bank donor corneal suitable for PK or DALK. You can see that we put in same manner that we perform in corneal bank eye, and we put this in the cornea, and this is the results, and I show this because it's no published, this is under review. You can see before and after, after 1 week, you can see that before and after 1 week that we insert this lenticle, and this is the lenticle that we do in a red vision that is clear. Here, you can appreciate the anterior corneal topographical change in central of keratoconus that is evident with differential corneal map that you can see here. And here you can see the difference in anterior segment OCT before and after the SLAC that we performed. And here, at the last, you can see that we have all the cut that we can study with the confocal microscopy. Preserve the epithelial morphology, minimal nerve damage, lenticle keratocyte, lenticle loss interface, porcino stroma. We haven't problem. Minimal nerve damage, we haven't problem, like with SMILE, because the technique is the same, and the tolerability is very, very good. You can see in present slide. And here is the next step that we performed with the group of Donald Tan of Singapore, where we prepare this decellularization of a human stromal refractive lenticle to perform and generate a transplantable bioscaffold. In conclusion, you can see that the negative meniscus in the stromal lenticle implantation appear a visible technique for reshaping the cornea that we call SLAC. The topographical and morphological findings indicate consistent and reproducible variation because we perform until today in 12 patients. The corneal flattening achieved with the stromal technique represents an interesting treatment option in corneal ectasia. Further studies are needed to assess the ideal profile for achieving the best corneal remodeling in different cases. Why? Because it's possible to perform in pellucida, it's possible to perform in decentration of keratoconus, because you have seen that we perform this only in central keratoconus. Thanks a lot for your attention.